Greetings to one and all. My name is Singh, a research scholar from Sha University, Greater Noida. Today I'm here to present my research paper with the title name Benchmarking Facial Emotion Recognition Models Using Deep Learning in Comparative Study, the paper ID 481, with the track Artificial Intelligence in IoT, me being the author, Prime Author Singh, and my co-author, my guide, Professor Pamanand. Okay, so let's start with the introduction of the paper. Facial emotion recognition is a process of identifying emotion from facial cues in images or videos. So basically, I have done the comparative study of various facial emotion recognition models being developed or being worked upon these days. And emotions can be recognized through the images as well as the videos. It is a challenging task as emotions can be expressed in subtle ways and can be affected by factors such as pose, lighting, and facial occlusions. So basically the most challenging task these days that has been encountered with the recognizing the emotions is the occlusions. Means if the face is hidden by something with the hand or something, or the pose, unposed images are very difficult to for identifying the emotions, and obviously the lighting effect also affects in the process of recognizing emotions from the face. The most recent technical developments have created the new avenues for automatic face expression identification. So the technical advancement these days, with the advent of deep learning and all the advanced technical developments, it has now become a little easier for it has become easier to overcome all the challenges which were earlier there, as well as far as traditional methods were concerned for identifying the emotions through the face. And real-time facial emotion recognition has also existed these days because of the advancement of the technical developments. One technique for facial emotion recognition is the use of convolutional neural networks. So convolutional neural network has basically is the basic, force behind the advancement or basically the success of recognizing the emotions through the face. So continuing with the introduction again, in the context of FER, CNNs can be trained to recognize emotions from facial images by processing the images through multiple layers of artificial neurons. So CNNs are, as we all know, convolutional neural networks best used in image processing. And here also, that images, first the model is being trained, the model is fed the images, it is trained on various images, and then it is being tested. The final layers of the CNN then use these features to make predictions about the emotions present in the image. This approach has been shown to be effective in recognizing emotions from facial expressions, with CNN-based systems achieving high accuracy rates in many studies. So as I said earlier, also CNN is the basic task force that has really helped in processing images. And as far as my domain is concerned, the emotions from the faces has been possible through the CNN only. So this is the basic methodology used for recognizing their emotions from the faces. Basically, 7 types of emotions are being worked upon. So starting with, we need initially a database which contains hundreds of thousands of images. It is used for training the model. So images from the data set are being pre-processed. If they're not in the pre-processed form, they are being pre-processed, they're normalized. Various normalization methods are existing for normalizing the images. And then we do the feature extraction, obviously for recognizing the emotions. Some prominent features like the eyebrows, your the lips expressions. So these are the very prominent features of or which determine the emotions in a person on a person's face. So those feature extraction is also done in this. Then the classification models. Classification model basically is used for that will classify, okay, that this image is of angry, this image is showing the disgust emotion, this is showing fear, and so on. Finally, the result is the classified emotions from the set of all the various images present in the data set. So this is the basic methodology behind facial emotion recognition. Next is the CNN architecture that I'll be explaining. First of all, it was proposed by Lee et al. And used in various applications today for image classification. From not only it's limited to image classification, it also working these days on all audio synthesis in the WaveNet. These are special neural networks for processing data with grid-like topology. CNN takes images, and from them they learn the patterns, the building blocks that make them up. CNN basically constitutes the three layers. First is your convolutional layer. Convolutional layer, what is the job of this convolution layer? The data or the image is convolved using kernels of filters on the convolution layer, which is the topmost layer in the CNN. So the first layer is the convolutional layer. Basically, the image, which is the pre-processed image, which is just being fed to the model, that has been convolved, basically been identified for the basic emotion or the prominent feature. In essence, the filters are sliding windows. Since they are the little units applied to the data, the filter has the same depth as the unit. So filters are basically used. Small filters are used on the images, and the work of these filters is basically for identifying the prominent features which will help in determining the emotions from the images. The output of the filter applied on an image will be convolved feature containing the prominent feature for further processing in the layers ahead. Next is the activation layer. Activation functions, which are nothing but the mathematical functions that are utilized to decide whether a given neuron should produce an output based on input values, bias, or weight. So an activation function is which are as we all know, the mathematical function that basically decides which neuron of the layer is holding the most prominent important information regarding the feature that will help in identifying the emotion, which should be fed to the next layer. All right, so activation function has a major role here, and not only non-linear activation functions are used because between subsequent convolutional layers, and these the activation layers, the activation functions which are basically used are ReLU or leaky ReLU. ReLU is nothing but rectified linear unit, is used for activation function, and leaky ReLU avoids the dying ReLU problem. So basically for the emotions and the extraction of emotions and identification of emotion, the type of activation function used is ReLU here. Third is the pooling layer. Pooling layer in a CNN involves the downsampling of spatial dimensions of the input feature map so that less parameters are learned during training while retaining the prominent information. So pooling layer, basically the job of the pooling layer is now to identify the best feature from the convolved image, which will definitely help in identifying the emotion from the face. That would be the most prominent feature through the face, because the eyes, the eyebrows, the lips, as I said earlier, also these are the prominent features, whereas the cheeks, the chin, all these features hold less importance in identifying the emotions. Hence, this is the work of the CNN model, that it provides with the prominent features that will move ahead and one helps in classifying the emotions through those features. So pooling layer plays an important role there. So we do not want our model to get trained on less prominent features. Hence, the pooling layer is used in training, which retains the prominent information. This attainment by pooling layer involves learning the attributes in the local neighborhood of the input feature. So that's the basic architecture, as I just explained, with all the three layers. And the input layer in the so the input image is fed to the convolutional layer. Then the chunk, or the basically a grid-like structured part of that grid-like structure is fed to the next convolution layer, where the images are convolved, and the best out of those features is extracted there, and then it is fed to the pooling layer. The pooling layer then take those prominent features from the convolved features and then send it to the fully connected layer. After the fully connected layer, finally the emotions are being classified into the various categories. So data sets basically used for facial emotion recognition. The most famous ones are the CK+. It consists of 593 expressions in both the post and post videos, and it basically has 7 emotions, the 6 basics one, and with the neutral one, and the content one. FER 2013, the next, has the widely used and the most complex data set used in identifying the facial emotion recognition, and it consists of 35,887 images with grayscale, in grayscale, and it also classifies 3 emotions. It also contains 3 emotions: angry, disgust, fear, happy, neutral, sad, and surprise. JAFFE database is database of 10 Japanese females with exhibiting various emotions. So it consists of 213 grayscale images of these 10 Japanese females. It also contains 7 emotions types. KDF contains 4,900 images of the human facial expressions, also with 7 categories of emotions. SFEW 700 photos, each having unique age, lighting, head posture, and occlusion, again with 7 different emotions. Multiply, more than 750,000 images are reported, and 19 illumination condition, 115 views. And the emotions are happy, neutral, disgust, squint, surprise, scream, and anger. AffectNet is also a huge database consisting of 440,000 images, which are collected basically from the web or the wide, you can say. So also containing 7 emotion types. MMI, on the other hand, it consists of its video. It gets a database containing video images, videos, and the images from those videos are then extracted and then been classified for various emotion types. Again, it helps in identifying 7 emotions. So these are the basic data set that I came across after doing the comparative study from various existing studies till now. So okay, this is the comparative study that I had done. References being given here will be references are mentioned later on the slides also. So reference number 11 says that it has used dataset KDAF, and the issues faced by it was less amount of training data was used. So in obviously in the ML models that we use these days, if we train and obviously with the deep learning, when you talk about deep learning, the more the data, the more the training data, the better the result. So if a model is fed the less amount of data, it gets less trained, and there are chances that it does not predict and gives the poor efficient result. So this was the issue with this paper, and it showed an accuracy of 88%. FERC 2013 was used by this paper, and accuracy can further be improved in it as it's quite low, although this data set is also quite complex. So the accuracy achieved here is 70.14%. From 17th reference, I could say that manually collected static images. It took the data set with the manually collected static images, and it created problem with 2 of the emotions, that is anger and fear, and hence the accuracy was 75%. From third, I can say that CK+ was used, results in misclassification of few emotions, and 92.81% of this accuracy was obtained. From the 5th reference in the paper, using a 48 MP camera, 5 different facial expressions were carefully recorded, and the issues faced by this was found in this was limited number of emotions are classified. Only 5 emotions were classified in this paper, and the accuracy obtained was 78.04%. In paper number 18, JAFFE dataset was used, and 2 face features, the lips and the eyes, are all that are used to determine the outcome. Although other features like the eyebrows get also used in an emotion like surprise, so that was missing in this paper. and the accuracy varies somewhere in between 70 to 95%. Paper number 18. In paper number 20, dataset was not mentioned, and might be the bile dataset or the dataset of one of Ohms was used, and the poor accuracy compared to higher light intensity in cases of inadequate elimination was encountered here, and an accuracy of 86.70%. So this was the comparative study of various facial emotion recognition work being done till now. Few of the references from my paper I have mentioned here. So these are the references. One more. So all of you I have mentioned here. That is it. Thank you so much for being such a patient listener. Thank you.